Hello everyone, in this video we will be implementing a deep learning based chatbot using DialoGPT from Huggingface and streamlit chat from Streamlit. The chatbot gives human-like answers and all of the code will run on your local machine. So let's start with the coding. First we will import auto model for casual LM and auto tokenizer from transformers. I hope you already have transformers installed using pip install transformers. We will also need torch, then we will define the tokenizer and the model. And firstly we will have a run function, so we will say def run user text comma chat history IDs. So now let's see the theory of the chatbot. So let's say you gave an input hi to the chatbot. So what will actually happen is the particular hi word, it will be given to the tokenizer, the DialoGPT tokenizer, and some embeddings will be created. As you can see on the screen, the embedding right now has cream and blue color. So this is the input embedding. This input embedding will be given to the model and the final output embedding will be created. One thing that you need to note here is all of these embeddings are of the same size. However, I am showing you the smaller size out here because these are the size of the actual embedding. Rest everything is padding token. But when you see on the top, that is the output embedding, one interesting thing that you can see is the input embedding, that is the cream color and the blue color has been maintained, but one orange color has been added, which means the input is there in the output. Okay, this is something that is very important. And as you can see in the text also, you have hi, which is the input, then there is a separating token, and then there is the output of the model. So this is how the output and the input is related in DialoGPT. So now what happens in the next iteration? You will see that in the next iteration, let's say you gave the input are you free to the tokenizer. So obviously in the last step it gave you hey, and then you replied are you free. Then obviously this will go to the tokenizer, and one important thing that will happen here is obviously there will be some embedding of the present. However, the entire embedding of the past will be taken. So let me rephrase that. The entire embedding of the past will be taken. That is, as you can see over here, the starting is cream, blue and orange, which is maintained. And then the input embedding of the present, that is yellow and red, has been added. So all of the history and the input of the present tokenizer is also added. So this is how it maintains the context over long durations. And then all of this is being given to the model, and the final output is taken. So once you have the final output, you can see starting from the first, that is the cream, the blue, orange, yellow, red, and the final output white and brown in this case. So as you can see in the output, right from the start, hi, separating token, hey, separating token, are you free, and then finally you have the no, that is the response of the model. So let's say if you just want the response from the model, you will say I just want the text whatever is after the last separating token. So now you have already seen the pattern. Let's see what will happen in the third case. Obviously in the third case also you will be giving some input. Let's say you are giving some unrelated input. You say I am 41 and then you give it to the tokenizer. What happens is that the last final output that we had gotten over here is first taken, and then the present input tokenizer output has been added, or the embedding has been added. So obviously till this brown over here was the last, and in this one we added light blue. Okay, and what happens again, it will go to the model, and then again some more output will be predicted. However, all of the history will be maintained, and lastly you can see the purple and the dark brown has been added. Okay, so this is how it goes, and again this thing operates for all of the steps. That means it will go for as many conversations that you're going to have. So this was the theory, and let's implement all of this in code. So first we will write input IDs and then encode the input user text. So I'm going to say tokenizer.encode and then pass the user text and the EOS token and return tensors as PT for PyTorch. In the next line, we are going to see whether this chat is the first chat or not. And for that, we are going to see if chat history is none or chat history IDs is none, we are going to say bot input IDs, whatever we are going to give the model, is equal to the input IDs. Else, if this is not the first time you are chatting, then we will concatenate all the history as you saw in the slides to the present input token. So we will say bot input IDs equal to torch.cat for concatenation, and then chat history and input IDs, all of that concatenated in the last dimension. Then we have to give all of this to the model. So I'm going to say chat history IDs, which is basically the output of the model, is equals to model.generate bot input IDs. We'll keep the maximum length to 1000, and then we'll add the pad token as end of sentence token. Lastly, what we are going to do, we know that the output of the model is only the output after the last separating token. So we are going to say resp, which is response, equal to tokenizer.decode. We are not going to tokenize everything. We are going to say chat history of, and then we are only going to tokenize the last part by writing this. And again we are going to say skip tokens or skip special tokens equal to true. Lastly, we will return the response and we will also return the chat history IDs. We will save the entire file as run model, and now let's go and write the front end of the program. So I already assume that you have Streamlit and Streamlit chat already on your computer. So you can write pip install Streamlit and pip install Streamlit chat. And then what we are going to do, we are going to import Streamlit, Streamlit chat, NumPy, and from the last file which was saved as run model, we will import from run model, import run, the function run. Now we are going to see whether we have two session states or session variables. So first is chat history ID. So if chat history ID is not in session state, we will initialize it, and then we will also have another session variable as book, and we will also initialize it if it is not there in the session state. Next, we'll have a text input for getting the text wherever the user is going to pass the text. So I'm going to say text equal to st.text input, and we are going to give a type here label. Then if the input is there, that is if the user has actually given a text, we will run the function. We will say resp comma hist. So resp is the response and hist is history, equal to run, that is the function that we have defined earlier. We are going to pass the input text, so we are going to say txt and the chat history ID, whatever is there till now. Then we are going to append the history into the present chat history by writing st.session_state chat history ID is equal to hist. Now what we need to do, we need to do two more things. One, we have to include whatever the response and whatever the text is given in the book list, and then finally print the chat. So for that I'm going to write st.session_state book.append, and we have to append two things. We have to append the message as txt, that is basically a dictionary. We have to have a dictionary where one key is message and text, and the other key is whether this one is given by the user. Well, the txt variable is actually given by the user, so I have to say is user equal to true or :true for the dictionary. Next, we also have to append the response of the chatbot. So for that I'm going to say st.session_state book.append. In the message I'm going to give the response, and since this is from the chatbot, I have to say is user equal to false or : false. Lastly, we have to display all these messages. So for that I'll open a for loop. I'll say for I comma chat enumerate st.session_state book, because this is actually that is going to save our all the chats. And then finally I have to say st_messages chat with you'll unpack the chat, then the comma, and finally we will pass key equal to str of I. So as you can see, the chatbot is ready, and whatever message that you want to give, you can give, and the response from the chatbot is shown over here. As you can see, the chatbot is very good and the responses are pretty human-like. So this can be implemented in for all the projects that you want, or even your basic projects. If you have some custom projects where you want to fine-tune your chatbot for a different thing, however, that will be difficult because it will ask you for a lot of training examples which you might not have in the first place. However, this could be a okay enough start. If you're wanting to just have a chatbot that you can chat to, this is an amazing thing to work with. So I hope you understood the video, and bye.